I won't be able to make it in Spanish more than that, so we'll do English now. So the art of PostgreSQL. So who's been using PostgreSQL already? And as a developer, or maybe a DBA, or so developers using Postgres? Yeah. Okay. So let's get started then. So the talk tonight is mostly for the developers. Okay. So we're going to see what is this thing PostgreSQL and what is it relevant in your life as a developer. So like Alvaro said, I've been contributing to PostgreSQL for a long time now. I'm currently working at Citus Data. So we do sharding on top of PostgreSQL. Citus is an extension that you can install, and then you can have several servers participate into the same formation or cluster, and you can have data that is sharded. It means that any one server will only have a part of the data, not the whole data set. Which means also that every table is smaller on the server, every index is smaller, so everything is easier and faster. For sharding to work for your case, you need to have a sharding key that is well defined, and that helps with the performances of your queries. So if you have a big volume on PostgreSQL and you're not sure what's next, maybe have a look at Citus. As Alvaro mentioned, I wrote a book. That's the book I wrote. It's over there. It's called Mastering PostgreSQL in Application Development. And you know, the path to mastering, it's that you practice and practice and practice again. Like if you picture someone learning how to play the piano, maybe, or the guitar. I think guitar is more maybe common in Spain. If you want to be good at the guitar, you get to play every day. Whatever happens, you play your guitar like 10, 15 minutes, and then more and more and more. So it's the same with anything really. So it's the same with SQL, and so that's why the title it looks a little like wow, mastering. What does it mean? It means that you have to do it every day. Otherwise, you're not going to be good at it. And just for you guys, so PGES Meetup, because it's the Meetup in España. So you can have a nice discount if you want to. Sure. So why PostgreSQL? Why would someone use PostgreSQL when developing an application? So one answer that I often hear, I've been doing lots of consulting before. So a classic answer that is wrong is storage. It's to care about storage. Well, storage is easy, right? If you're doing Java, I hear that in the Java world, XML has been popular for a long time. So if all you care about is storage, you just serialize your object instances into XML, and that's it. You have storage. Nowadays, like the #1 storage solution in the cloud, it's S3. It's not a relational database thing. It's just files in the cloud. In the 60s and 70s, it used to be that the memory that you had on the computers, when you did unplugged the power socket, the memory didn't change. The bits were like physically available, and the memory wouldn't change for a couple of weeks, maybe 3 weeks. After that, you can have bugs, like physical bugs, go into the machine and change the bits around. But for a couple of weeks, if you unplug and then replug the machine, you have exactly the same memory as 2 weeks before. So storage has never been the problem that relational database management system solved. So what's good about PostgreSQL? Why using it? Well, database management system, they're good at concurrency and isolation. So maybe everybody of you have seen this picture before, theory and practice. So you'd like things to be like well organized, and here we can see a very nice concurrent activity. Everybody doing his own thing in his own side of the world, and everybody happens in parallel concurrently. Everything is fine, but that's the reality of it if you don't pay attention. So RDBMS are for solving concurrency and isolation. A database system is handling concurrent access to the data, which means that in your application at the same time you can have several backends, processes, threads, whatever it is that you're running, that are accessing the data, the same data set at the same time, and you ensure the same business rules for everybody. If you're selling things, for example, you can make it so that the last item in the stock, there is only one, let's say one book left, and two people want to buy it. Only one of them is going to get it. That's concurrency, okay? So how do you implement concurrency with a database system? Well, the database system is going to do it for you, so you don't have to care, and they're going to implement those four basics things. So it's ACID. Everybody has heard about ACID before, right? So the main thing about ACID is that mostly when we learn programming, maybe at school, maybe somewhere else, when we are introduced to databases first, we're going to assume that it's going to be ACID, right? Because that's what the database is good at. Currently, with the NoSQL movement, NoSQL is making a lot of trade-offs that are really interesting, depending on your use case. So there is nothing wrong about it. It's just that as a developer, they are not providing ACID to you. They're always removing one of the four letters. So I like to pick on MongoDB because it's easy, really. So forgive me about that, but let's pick on MongoDB. So MongoDB doesn't have transactions, right? By design. So it doesn't have atomic or isolated. MongoDB is schemaless. That's a feature. Schemaless means no consistency. There is no way you can guarantee anything about the data because it's schemaless. It's the job of the application to care about the data consistency, not about MongoDB. So MongoDB doesn't have the A, the I, the C, and it used not to be durable at all. They say they fixed it, but I'm not sure if it's true or not, but up till late in the game they didn't have it. Which means MongoDB is a fine product, but if you approach it as a developer with a mindset of a database system that for you is going to be ACID and offer you those guarantees, well, you're in for a lot of trouble because it will not guarantee anything like that to you. Some other systems have transactions but no isolations, or maybe they are not durable because they are like highly available platforms, but you cannot have a backup, a consistent backup. You cannot do that online. So if you don't have a consistent online backup, can you be durable, etc., etc. So it's always trade-offs. With PostgreSQL, you have all of that. So let's see into it. Sorry. Atomic, it means you can roll back. So if you have friends, or if yourself, you're doing Oracle DBA stuff, a nice trick to play to Oracle people is begin, drop table, roll back. Because in Oracle, when you drop table, the transaction is implicitly committed. Okay, it's game over, that's it. So when you do rollback, there is no transaction in progress. And Oracle would be really proud to say you that. Oh, no transaction in progress. Sorry, you lost the table. But with PostgreSQL, when you drop table and roll back, it just rollbacks and you get the table back. It didn't disappear. So even the DDL is transactional in PostgreSQL, which is unique in the relational database management systems. The thing is that usually developers or even DBAs, when you're on the production system, you don't type in rollback. Rollback is not something that is often asked for the database to do. So what's really the feature all about here? Think of this problem that everybody had in production at least once. File system is full, right? Who saw file system is full already in production somewhere? Yeah, most of you guys. What happens is that if you have your application and you have a migration script, so it's an upgrade of the schema. You're doing begin, create a new table, alter a table to add a new column, maybe drop another column, maybe do several things like that. So you're going from schema version 1 to schema version 2 of your application. And right in the middle of it, file system is full. What's next? With PostgreSQL, what's next is rollback. So you get back to version 1 of the schema. With about any other tooling in the place, what happens is it began right and then it stopped. So you don't have version 1 in production anymore of the schema, and you don't have version 2 neither. So what do you have in production? Nobody knows. You get to figure it out. And is your current code running in production compatible with this thing that nobody saw before? I bet not. But that's what happens. So if you don't have atomic, if you don't have rollback, and rollback on the DDL, that's important, well, your application needs to take care of everything that is related to having a problem in the middle of a transaction. With PostgreSQL, PostgreSQL is going to take care of it. And remember that as a developer, when you ask for commit, the answer might be rollback. So the fact that you send a commit message to the application is not relevant. What is relevant is the fact that you got back the commit message, because it might be rollback if the file system is full. Okay? Then consistency, because ACID, so AC, the C is consistency. In PostgreSQL, it means that you have a schema. PostgreSQL is relational, so it needs a schema to work. By the way, relational, it doesn't mean that you have foreign key support, right? Lots of people think that. I don't know why. Relational means it's like in mathematics. In math, a relation is a set of data that all look the same. So we speak about domain attributes, and we speak about tuples. So what is a tuple? If you have only one element, it's a singleton. If you have two of them, it's a couple. Three of them, it's a triple. Four of them, it's a quadruple. And if you have t of them, it's a t-uple. So that's a tuple. So in French we have another name for it, but anyway, so it's a t-uple in English, so a tuple. And it means that here we have a tuple with only two elements, integer and text, so it's not very interesting. And so this table is a relation because it handles a set of data with the guarantee that every single tuple in there has the same data type. The data type is named foo. In PostgreSQL, when you create a table, you also create a data type named the same as the table. So foo is both a table and a type, and the table is a list of entries of the data type. And the data type is composite with an ID and F1 with field number 1, so integer and text. Not very interesting, but that's what a relation is. And in relational database, we talk about constraints. So not many people, I don't know any really, nobody likes constraints. Who wants to be constrained, right? Nobody wants that. Everyone wants to be free and do whatever they want to. It's not possible, of course. But in database, we call it constraints. We should rename it. It should be called guarantees. It's business guarantees. What you implement with constraints in a database is a strong guarantee. Here, I guarantee you that the ID is going to be an integer. So I picked on MongoDB already, so let's switch and now pick on MySQL. In MySQL, if you say that you have a date, that time is a data type of MySQL. It's like a timestamp. They're going to accept year 0, which doesn't exist in our calendar. Our calendar goes from -1 to 1. There is no 0 in the calendar. MySQL will be happy with it. It can even handle days being 0 or months being 0, which has no sense at all. And I had a customer once tell me, yeah, but it's it's a monthly event, so we don't care about the day, so the day is 0, of course. I'm like, yeah, but why do you call it a date? It's not a date anymore. It's not datetime. It's not timestamp. So if you're using PostgreSQL, you have the strong guarantee that the data types are going to be actually valid, and that you can trust the data in the database to be like what you need. If you have a table with, for example, a timestamp like start date and end date, and you don't have a constraint that guarantees that the start is before the end, just run a SQL query to see about that. How many lines have the two of them reversed? If there is no check constraint, I guarantee you there will be some, because things happen. So that's consistency. Then we have isolation. Isolation is the other side of atomicity, and sometimes it's not easy to think straight about them. So the nice example is pgdump. Isolation means that while your own transaction is running, of course nobody can see what you're doing until you commit. Okay, that's atomicity. Isolation means that you don't see what the other guys are doing. So let's say you select const from a table. Then someone does an insert, and then you do your const again. Do you see +1 or not? So if you're isolated in the default isolation level in PostgreSQL, which is a read committed, you will see the +1. If you're in repeatable read, you won't see it. You will keep the same snapshot of the database, which is really is a snapshot like in the photography or a frame in a movie. It doesn't move. So if you take a snapshot, like read committed is the default, so if you want repeatable read instead, then you will work for the whole duration of your transaction with the same data set, and you will not see whatever happens in parallel to you in the rest of the database, in the rest of the system. Of course, pgdump is using that, because it wants to dump like a consistent backup. So it will use the same snapshot from the beginning to the end. It will not mix and match like old and new transactions in the same backups. It would have no sense for your application, right? Then you restore the backup, and maybe you have like half of the work that a couple customers did in like several transactions. That would be strange. Like you would have like payouts, but you wouldn't have the accounting done yet, or makes no sense. So it's the same snapshot from the beginning to the end. And then durable. Durable, it's the socket plug trick. Do you know that, this test? It's a really nice test. What you do is you set up a database system, and then a small application, really small. All it does is, so you create a table, and then you insert into the table, and you commit, and you count the commit message you receive back. That's the important trick. You only count +1 when you receive a commit message back, okay? And then in the middle of the test, you unplugged the database server, like physically unplug it, and then plug it again. Durability in SQL, it's the guarantee that whatever happens, when the system said commit, it is not allowed to lose the data. So then if you count how many commits you had in your application, and how many rows you have in PostgreSQL, it should be the same or more in PostgreSQL. If it's not the same or more, it means the system is busted. Either the hardware is wrong, faulty, or maybe PostgreSQL is badly configured, for example with fsync off or things like that. That shouldn't happen. Or maybe if it's not PostgreSQL, you have like a buggy system and you should migrate to PostgreSQL already, because that's, yeah, maybe you want to do that. And so that's it. So ACID is basic, but that's what every developer by default will think about their database system, and it's implicit nowadays. So you don't get to explain ACID a lot nowadays. So that's why I took some time to have a fresh memory about it and see what it means really. And it's a really nice property of the system. So why using PostgreSQL? The first thing is because it's fully ACID, and it does it for, like, it's the real thing. It's not halfway through. It's actually you can trust your data to PostgreSQL. And again, it's not about storage. It's about concurrent access to the data. Like some people are going to do select, some other inserts, update, delete, etc. Everybody is going to do that at the same time in their own transaction, and it's fine. PostgreSQL will take care of everything. So that's the number one reason to use PostgreSQL. That's transactions. The other reason is SQL, and so who likes to write SQL queries? So my hope is that by the end of the talk, more of you will raise the hand, because my well, usually when I do the kind of, not this talk because it's the first one I'm doing, this one is just for you guys, but when I do this kind of talks, people realize that they don't know SQL. So they're like, you cannot do anything in SQL anyway, or it's a bad language, I don't like it. It's not even a programming language common. And then by the end of the talk, they're like, oh, you can do that in SQL? I didn't know. So let's see if it happens for you guys. PostgreSQL is object-oriented, and I will get to that back in a minute. It has extensions, many of them. It's awesome, and I will show you some example of existing extensions to see what it means to have extensions in PostgreSQL, and it's related to being object-oriented. So you can extend what PostgreSQL is able to do with a simple extension that you can deploy at runtime. Rich data types, data processing, advanced indexing, arrays, XML, JSON, all into the database. So it's just a couple things. I could spend like a whole hour explaining feature after feature of PostgreSQL. The manual is like 2,000 pages long, and there is everything is written only once. And people usually, the number one complaint about PostgreSQL manual, the more than 2,000 pages of it, is that it doesn't cover everything. Okay, so some things are covered, but like in a single line, and people would want a full chapter of it. And so also the documentation of PostgreSQL is awesome. You should read it. Contrary to many other products, in PostgreSQL, if you send a patch that is awesome for performance reasons, but you don't modify the documentation in your patch, the patch is refused, full stop. If the change you're implementing is user visible, it needs to be documented, otherwise it's refused. That's it. Which means that we have a really, really great documentation. Everything is documented. So if you're not used to reading, because many developers, when they have a SQL program, they will, of course, do a Google search, and they will find blog posts and read them. It's nice because it's a good introductory material, but maybe the blog post is some years behind, maybe etc. So as soon as you know the concepts in SQL you're interested into, go read the manual, the PostgreSQL documentation. It's really, really great. So now that you want everybody to be using PostgreSQL, how do you do that? So as Alvaro said, I've written PD loader. So basically it's a single command line. You have the source connection string, the target connection string, and it does everything for you. It will migrate the table, the schema, the columns. It will map the data types in between the source and the target databases. It supports in source. You can have PostgreSQL, MySQL, SQLite, Microsoft SQL Server, Redshift, and then flat files like CSV and things like that. And as a target, PostgreSQL. And it uses copy. So it will recreate the schema, then copy the data over on the fly, change, for example, the 0 dates in MySQL are transformed on the fly to being null in PostgreSQL. So we change the constraints in the schema before we do that. And at the end, it recreates all the indexes, foreign keys, etc., etc. So check it out. The whole goal of pgloader is that you have no excuse. If you want to play around with PostgreSQL, but you're currently stuck with, let's say, MySQL or SQLite or something else, it's one command line away. So just, play around and see what happens with PostgreSQL. And of course, it's open source. It's on GitHub, and you can participate, you can contribute, you can open issues, etc. So let's continue with SQL for developers. So not all of you said they would like to write SQL queries. So let's see if we can have an impact on that. So the first example that we're going to use is because it is the data is easily available and everybody can relate to it pretty easily. That's from the New York Stock Exchange. It's really simple. You have a date and 3 numbers. So that's the number of shares that were sold that day or that changed hands. The number of trades. So that's that many shares in that many trades, and the amount of dollars that is related to it. Okay? So that's easy, right? Thing is, because we have commas and dollars, and we cannot directly load it in PostgreSQL as numbers, so we're going to load them as text with a copy command. Copy from the CSV with delimiter, etc. So that's a single command, and it works. Okay? And because it's /copy, it needs to run on pSQL, the console, the PostgreSQL client tool, and it's going to read the data on your local disks and upload it to your database server. So the database server can be on another machine. You have the files on your laptop, and you upload to RDS, for example. That's just /copy. Okay. And then, because we want the numbers really. So we're going to replace the commas with nothing, and the dollar sign we're going to start at the second character of the string, not the first one, and with a substring, and we're going to convert that to being int and numeric. Numeric because when you deal with money, you need to have digits after the comma, and you don't want them to be like a floating comma, right? You want to know how much money you have in the bank, and you don't want an approximation of it. And you want the computations to be exact and not floating. So you use numeric for money always. And so who knew you could do an alter table that rewrites 3 columns in a single statement using like any text processing facility of PostgreSQL? Ah, yeah, you didn't know you could do that. I'll say it again. So you can alter a single table, like rewrite 3 columns in one command, and you can use any text processing facility that comes with PostgreSQL or anything really, any functions here. So only you could do that, like one command, 3 different columns, 3 different expressions with casting, and you get a rewrite from text to whatever you want to. Okay, so that's SQL 101, right? Okay, let's continue then. Another thing that most people tell me about SQL is, when I write some code, I can master the algorithm I'm going to use. When I write SQL, I have no idea what's happening. So I prefer writing my code. So let's take an example in Python. We're going to do a top 10 here. And let's say we have a file with 1 million lines. So it would be kind of stupid to load 1 million lines in memory just to output the 10 most, the 10 numbers, highest number. See, it's decreasing in order. It's bigger, etc., etc. And with the date. So in Python, when you want to do that, and you want to keep only 10 elements in memory at a single time, so who's been doing Python before? Yeah, but it's the same concept in many languages. But you use heapq here. So it's heapq is it's a data structure, right, that you have in any programming language. And so you initialize the heapq and you heapify it in Python. That's the API. And then the API is called heap push pop, which means that you push a new line in the heap, but if the heap is full, you're going to pop another one. Okay, so you guarantee that you have a heap with only n elements here. N is configurable, and then at the end of it, you get the n largest from the heap. Okay, easy, right? And you control what happens. You know that at any time you have 10 elements in memory, so you know what you're doing. So who knows how to write that in SQL? So I will not ask for real the question because it's so easy, right? It's that in SQL. So if you want to be formatting your SQL code, it's 4 lines. It could be a single one, but it would not be as clean. So 4 lines of SQL and limit 10, and then you have the 10 lines, the same ones, of course. But how do you know what happened under the hood? So what you do is you explain your query. PostgreSQL is really nice at that. So it takes some getting used to be able to read an explain plan. So I will not do the full lesson on it tonight. Basically, it's from the inner side to the outer side. So it begins on the inner side. So it begins with a scan of the table, and it reads that many lines in that many milliseconds. So it's 0.6 milliseconds to read the table. It outputs those columns. And then, oh, sort method, top n Heapsort. Reminds you of something? I thought so. And it used 25 kilobytes of memory, because it knows that each row is only 12 bytes large, and there are that many rows, and we want only 10 in the results, so it can compute how much memory to use for the top n Heapsort. And if it doesn't fit in memory, then PostgreSQL will automatically switch to a sorting algorithm that is efficient for disk-based sorts. It's called tape sort. It was invented in the 80s, and in the 80s it was important to never read backwards. You only read forward because you had a tape at the time, and so the tape is running only on one direction. But to this day, the disks physically they are better at moving only in one direction. So it's still the best algorithm around, and that's the one PostgreSQL uses for the sorts if they don't fit in memory. So if I go back here, this algorithm, if the n here doesn't fit in memory, what's next? You need to implement something smart that knows how to deal with data that don't fit in memory. In PostgreSQL, order by limit, done. Fits in memory, very efficient. Doesn't fit, spill to disk, less efficient, still very efficient. Okay? So if you have an interview with a traditional question, how do you do an optimized sort, etc.? Say, oh yeah, order by. Sorting data is easy, right? You just write order by, and that's it. It's all, that's my favorite sort algorithm. It takes care of everything for me. Okay, so those of you not already using PostgreSQL, I guess you're discovering the explain plan. It's a really important to be able to read them. So, and those are the options that I'm using always. And be careful, analyze is actually running the query so that it can give you the actual time that the query has been using. So the query ran. So you can explain a delete, an insert, or an update. Just be careful to roll back after that. Okay. So the next question when we have this stock exchange data is going to be monthly reports. It's boring, but we're going to have to do it, right? The product people are going to want a monthly report. There is no way around it. So let's get it done. Here in PSQL, you can have variables. Maybe you didn't know that yet. So it's called start, and you use it that way with a column to say that it's going to be a variable name. And if you want the value to be quoted, you put the name of the variable in quotes. Okay? So it almost looks like a templating language. And oh, look at that. I said PostgreSQL is object-oriented. So you know that in object-oriented languages, you can have support for overloading operators, right? So here in PostgreSQL, if I say select 1 plus 2, plus is going to be obviously integer additions. So 1 plus 2 is 3. PostgreSQL knows that. Here I have a date plus an interval of 1 month. Well, of course I picked February, because otherwise it's not fun. So how many days is 1 month in February? Well, it turns out that PostgreSQL knows it. So the plus operator here is actually, it actually implements the knowledge of the calendar. So it knows what a date is, it knows what an interval is. Here it's 1 month. And it knows that in February 2017, it's not a leap year, so it's only 28 days. And all you have to write to get this knowledge is plus interval 1 month. And whatever the date here is, that works with PostgreSQL, okay? So that's one example of object-orientedness. Here is the result. Okay, it's boring. But there is one detail that is not, that we only have 19 rows. Oh, because there were days where the stock exchange is closed, weekends, I guess. So we don't have rows for that. But maybe your monthly report is supposed to be like sales in a shop, and you want to show the days where nobody showed up in the shop, because maybe you want to close on those days. It's useless to pay people to be in the shop if nobody shows up anyway. So maybe the monthly report should have the days without activity. So how do you do that? Who knows how to do that in SQL? Okay, so let's see about that. First, in Python, it's easy. Here you have the query, the same query, right? And you connect, you execute it, and you have the result. Here, you use the... So here, that's calling that function. Then you have the printing. It's a really easy code. And then you have this thing that is using a calendar implementation in Python to say, okay, I'm looping over the calendar, and if I have data, then I'm going to use it. And if I don't have data, I'm going to use 0 instead. Okay? That's easy for everybody, right? Even if you're not doing Python every day, you could have written that in any language, really. Here, what we see here, it's called the inner join in SQL, right? Because you have a loop over the calendar, and for each row of the calendar, you're going to do something else. So let's look at what you're doing. Here, day in data in Python, it's a lookup in a dictionary. So dictionary, it's an hash table. So this code here is a hash join. Okay? So let's continue with that in mind. Here is the result, of course. So nothing new on the planet, right? It's really 101. So let's do that in SQL now. But before we do that, why would we do that in SQL? Well, think about it that way. So this code is really, really simple, right? So maybe it's not a problem for this piece of code, but think about any code you would write. Where are you going to deploy that code? So maybe you have like the application server is now a Python Django. Maybe you are using like a financial analytics package written in Java that you plug on the same database. Maybe it's done internally, maybe not. Maybe you have like this new guy who's running Ruby on Rails in the same company. If it's a big enough company, you have a hodgepodge of every technology available anyway. And maybe there is this old internal business intelligence facility written in PHP because the CTO back in the day didn't have time, and it was quick to do. Okay, so let's say that you have this monthly report problem and you want to show it in more than one of those boxes. So maybe the smart thing to do is to solve it, with this guy. That's PostgreSQL logo, because some people are new to the community, so that's PostgreSQL, Python, Java, Ruby, PHP. Okay. So because in a single application you will have, like is written over there, you have many components. The front end, the back office, the analytics, the finance, the accounting, the invoicing, etc. It might be different teams if the company is big enough doing that, and maybe in different technologies. So let's do the days with no activity in SQL. So it's actually very easy, but the first time you see that, maybe not so much. It's always the same. When you know how to do it, it's easy, right? When you don't, you need to learn. So let's learn. Generate series. Who's been using generate series before? Yeah. Well, about the same guys who knew how to solve it at the slide before, so no surprise here. Generate series in PostgreSQL is awesome. It generates a series of data. Here it will start at this date and finish at this date. So it's the start date plus 1 month minus 1 day. See, PostgreSQL knows how to do that. You don't have to think hard about it in your application and fetch a calendar and compute that just to give a constant to PostgreSQL. You just say it, we start here and you continue for a month, but I want to stop just before the end of the month, so 1 day before, plus 1 month minus 1 day. And you go like 1 day at a time. It could be 1 hour, it could be 1 week, it could be many things. Interval could be every 17 hours if you need that. Don't ask me why, but I don't know, it's your case. So you can generate a series. So here it's going to be a series of every day in the month. Okay, and then you use that as a pivot table, and for every day of the month, we're going to do a hash table lookup, exactly like we did in Python, to see if there is activity or not. That's called a left join in SQL. And we join on the date, on the entry of the calendar with the date of the fact book. And what we do here, when we have that, is that, so the date we always have it. But then the shares, we might not have it, so we use coalesce function. Coalesce takes as many arguments as you want to. Okay, variadic function. And it returns the first one who is not null. So when you do a left join and there is nothing, no activity, so you have the calendar but there is no activity in the fact book, then here you're going to have a null that you turn into a 0 thanks to coalesce. Okay? Any questions so far? Oh, good. Yeah, it's easy. And here is the result. Okay. So that was easy. So the next question from the marketing department are going to be, what about the evolution week on week? So, like, I want to see the percentage of raise, or maybe not raise, that has been happening from the last Wednesday to the next Wednesday, because they notice that the activity is really tied to the day of the week in this sector that we are looking at. So they want to compare the shares sold this Wednesday to the Wednesday before. Who knows how to do that in SQL? Oh, okay. So here is it. This Wednesday we sold that much. Next Wednesday we sold, less, 10% less. This Wednesday, this, 7% more. Okay, so that's the result we want. So how we do it in SQL? We do it that way. So on the left, you recognize the query we were using before, right? It's exactly the same. It generates the zeros where we don't have data, and we generate a calendar even though there is no activity, right? That's easy. And we introduce that query with a with. It's called the common table expression. So it allows you to give a name to a subquery. So this subquery has a name now. It's computed data. And computed data is used here in the from clause. So the from clause introduces relations. Doesn't introduce tables. It introduces relations. The result of any query is a relation. The result of a left join, that's a relation. So anything you do in SQL, it's a relation. So in from, you introduce relations. So we're going to use the result of computed data, and we're going to do some other magic here. We're going to compute last week. So what's happening here? Last week dollars and over. So let's have a look at that. We have a lag function. And lag is called the window function because it's processing a window of data over a window. So you have all the data, and imagine that you have a small window that you're moving along in the data, and that's the window you see through the data. And so lag is going to see only the data in that window. So how do you define the data that goes in the window? We call it the peers. So there is a row, and you have the row as peers, like friends. And so who are the friends to the current row? Well, partitioned by extract isodo from date. So all the other rows that have the same isodo. Who knows what isodo is? So iso, it's the standard, and do is day of week. Day of week is the number you attribute to the, like Monday is 1, Tuesday is 2, etc., etc. But in some countries, Sunday is 1. In some others, Sunday is 0. Mostly, Monday is 1 is fine, but Sunday could be 0 or maybe 7. Depends on the countries. And some of them, Sunday is 1, so Monday is 2. Okay, so ISO, of course, is defining a standard so that everybody agrees. They don't, but there is a standard. We don't, so you can use a standard. And so any row that has the same day of week is going to be a friend to this one, and we order by date, which is important because we're going to use at the peer that is lagging one value behind, which means if your value here, if you only see the rows that are on the Wednesday, and you see one value behind, you're going to see last Wednesday, and then you're going to be able to compare like the dollars last week with the dollars this week and do a simple percentage computation. Okay? Really easy to do in SQL. And by the way, it's SQL from 92. You know, back when we had invented like, I don't know, IPv6, Unicode, things that everybody uses today. Right? So SQL 92, it's not even modern SQL. It's like SQL 101. If you don't know how to do that, you don't know SQL. I'm sorry about that, guys. But if you didn't know by heart how to do that, you don't know SQL. So it's good news. You have many things to learn, and it's going to be really fun. But don't tell me that SQL is bad because you don't know what it is. So I don't know about you specifically, but I had in consulting many people tell me, SQL is useless, and then they don't know how to do that, which was invented in '92. Okay. And so the result is exactly what we saw before. It's a copy-paste from the terminal. I just added some colors so that it's easy to spot what it's doing. Okay, but it's the actual result of the query. And again, I want to stress that it's an easy query. It's a simple one because it fits on the slide. The complex one that I do, they don't fit on the slide. This one, it fits. It's a simple one. And the current SQL standard is 2016. That's modern SQL. And each time there is a new edition of the standard, it means the previous one is obsolete. So SQL 92 has been obsoleted by SQL, so it was 89, then so 83, 89, 92, 99, 2008, 2011, 2016. So it's been a long time. It's been obsoleted by new standards. Okay. So if you want to write code in SQL, you need to think in SQL. So when you think in SQL, you need to think in terms of relations. If you do Java, they tell you everything is an object. If you do Unix, everything is a file. So if you want to produce music, you dump data to dev DSP, you have music. If you want to print a file, there is a file that represents the printer. You can cut a PostgreSQL file to the /dev/printer blah blah blah, and it gets out of the printer. So in Unix, everything is a file. In Java, everything is an object. In Python, you have packages, modules, classes, methods. You have several top-level concepts that you need to handle. And in SQL, you have relations. And the main trick of SQL is it's a declarative programming language, which means that your job as a programmer is to explain the result set you're interested into, not the algorithm, not how to fetch the data. That's the job of PostgreSQL. PostgreSQL knows how to fetch the data. Your job is to explain which data you are interested into. Okay. But because of joins, when you're not used to them, to thinking in relational terms, some people would think that the joins are expressing a path to fetch the data. They are not. They are expressing the properties of the data set you want as a result. And what is a relation in SQL? Well, each time you do a select, you describe the new relation, right? Select is named the projection, and it defines the query attributes domains. Okay, so in the SQL standard, you have attribute domains. That's what we use to define tuples. We said before that a tuple is a relation because it guarantees that everything is the same. It means it has the same attribute domains, one domain per element in the tuple. And so that's what you define with a select clause. With from, you introduce base relation that you will select from. Okay, it's pretty obvious. And the base relation can be composed. So you can compute new relations and use that as a base relation in your from clause. And to compute a new relation, you use joins or set operators, union, except, and intersect. And so inner joins, outer joins, lateral joins, everybody knows about them, right? And the differences and what they're used for. We'll see some more examples. So here is a nice query. Again, it's simple enough to fit on a slide. And in black here, it's relations. Okay. So from introduces a relation that is computed from a couple joins. So it's all the results with the driver IDs and the races. So basically, we have a database of all the Formula One's results in the whole history of Formula One. So if you like Formula One, it's for you. If you don't, well, it's easy to. It just races with people driving. And so you have the drivers and the results. And what we're doing is we're going to group by decades. So we compute the decades here. So each race has a date, and we extract with the date trunk. We can extract the decade. So the 50s, 60s, 70s, etc. And we're going to compute by decade, order by wins, limit 3. The top 3 drivers of every decade. And order by wins is a count star. It's how many races they won. So we're going to compute how many races any driver won in any given decade, order them, and fetch the top 3 of them by decade, and it looks like this. So if someone told you that you're driving like a Fangio, it used to be a compliment. Nowadays, not so much. It means you're driving too fast, and it's dangerous. But you can see Fangio, maybe you recognize Prost, who is French, so I like him. Schumacher has been winning a lot, and then nowadays it's Hamilton. Okay, so it's a single query, and you have the top 3 by decade. So top 3 by category in SQL. Usually when you do that, you use a left join lateral. Okay, it means that you're going to lateral means that you're allowed to see the other from relations that are at the same level as you are. So we're going to be able to pick into decades, and here we group by decades. You see, we extract the decade from the race again, and we basically this where is a join. Basically, we are allowed to pick into decades at this level of the query, and then limit 3, group by or the by limit 3, which means we're going to inject, we're going to loop over our result cells by decade and find the 3 winners by decade. So you inject a test here from decades. That's what we do with a lateral join. Okay. Oh, that's nice. I'm not sure what's happening. Maybe it was plugged, but maybe there is no electricity in the thing. Is the plug having any electricity? I didn't check that it was working. Maybe it's not. Or maybe it's not. No, it doesn't have any light. So sorry for the interruption. I'm not sure what to do. Yeah. Do we have another plug we could use? Oh, that's so fun.
Do you have to play Sunday on my computer, maybe?
I don't have her online. I don't have them online. I usually do that, but I didn't do check. Oh, it's back. Okay, maybe, yeah, 1%. But it has power now.
Looks like it's working. Maybe the plug, the plug was not working or was not properly connected.
So it's going to take some time to get back because it was no battery left at all. So any questions while we are waiting for the computer? So who wants to do more SQL than before already? We're not done yet, but yeah.
What is the longest query you have written?
No, it's like a couple, maybe 3 pages long, something like that. Not so crazy. Now, usually, as a consultant, when they call me to write a query, it was to optimize the performances of it. So usually, you don't have so long queries. So I remember one of them was like 2 pages long, and it had a budget of like 5 milliseconds. Maybe 10 milliseconds was acceptable. More than that, it was over, because it was for displaying advertising. Oh, it's back. And so for advertising, yeah, you have only 5 milliseconds. And it was up to 12 milliseconds in some cases, which was not acceptable to them. And it was like 2 pages long query, like double that, basically. And we needed to make sure it would run in 5 milliseconds. That was fun. That was fun. Okay, so any questions on lateral join and what it's used for? So basically, it's your manual looping in SQL. You can implement a loop in SQL by doing left join lateral, and here you loop over the relation you do, like the join. It's a where clause, but it's more like a join, because you see here the join clause is untrue. So basically, you push the join inside the query thanks to lateral. Okay. And so we had the top 3 pilots by decade. So if you want to see the top 3 articles by likes, maybe, or by number of comments, or the top 3 comments by number of people who answered to the comments, or things like that. The top n by category in SQL usually is implemented with a lateral subquery, left join lateral subquery. So left join lateral subquery. Okay. And so with that, if we think about it that way, SQL is code, right? So if you're going to tell that SQL is code, then you want tooling around it. So that's just a query that we saw before to illustrate what I mean. So many code bases around are using query, like for the SQL queries, you put them in a string in your code base, right? If you're doing Java, you will have a string in the Java code that embeds the SQL query. Do you want to embed that query into a string in the middle of your Java class? I know I don't. So maybe you don't either. I don't know. So you would like to have code integration, and you would the best thing you can do is have queries in .SQL file, so that your editor has like highlighting syntax for them, maybe auto-completion if you plug it and then connect to the live database and things like that. You want to handle parameters, and here we can see parameters. So that's parameters format that works well with pSQL. Maybe it doesn't work with JDBC, I don't know. But that's PSQL style parameters. And also, a thing that is like boring to do is mapping the result set of that into an object. So an object per tuple that you want to implement, and you want to set the attributes of the object with the results from the query. So most people would use ORM for that. Problem with ORM is that most of them are mistaken. They think that the R in ORM, which stands for relation, would be like a base relation, like a table you have on disk. That's stupid. We saw that before in this talk. A relation, that's the result of any SQL query. So if you want to use an ORM that makes sense, use an ORM that understands that the relation in the mapping between the object and the relational model, the relation is the result of a SQL query. And then you can do any SQL you want to, and you can have all the mapping you want to. The mapping is really easy, because the ORM, like they say, it's a really complex problem to solve. Of course, because they're not solving the problems that's interesting to solve. They're trying to understand the joints and redo basically the whole SQL technology and try to have it mapped to the object-oriented technology, which is completely different. It's another way to see the world. Relational and object-oriented is 2 different ways. But you don't care about that in your application. What you care about in your application is implementing the user workflow. So in your application code, you will drive one user at a time, for example, to fill in like a basket, a payment basket, and then buy the stuff you wanted to buy if you're Amazon or some other e-commerce website. If you're an airplane, you want to offer the possible travel routing options, and then have the customer pick one, etc. But basically, you're going to take care of one user at a time in your application code, which is really nice. At the database level, you're going to handle the whole thing, like how many tickets have been sold on this flight, do I have a flight attendant, etc., etc. So it's the whole story, the whole business is represented in the database system, and it needs to be consistent. It needs to make sense. And so if you're trying to map the whole system business rules into your application that is concerned about serving one user at a time, of course it's really hard to solve, but nobody wants to solve that. So the R is a relation, it's the result of a query, right? The query could be, you know, in the SQL standard there's a query named table. You do table foo, and it spits out all the rows from foo. So currently the ORM, that's all they know how to do, but what they should learn is to take SQL for what it is. And if you look at Juke for Java or POM for PHP, you will see that they do it that way. They allow you to write any SQL you want to, and they will map out the result of the SQL query to your dynamic objects in memory. And that's what's interesting. That's the right approach. So that's my slide about ORMs. That's it. And another way to do it is to use so Chris Jenkins did that for Clojure, because at the time, I think nowadays he's more into Haskell, but at the time he was doing Clojure work. And so he did YesSQL. I will show you an example. And you can have it in Python, PHP, C#, etc. And of course, it's really easy to implement in any language you want to. So if you're using something else that is not on the map here, take a couple days off, and then you will have the same thing, really. The principle is like this. You have a file called queries.sql, and here you have a query, here you have another one. You know you can use commands in SQL, right? Either SQL style commands or C style command with a /*, like I did before. So it's like any piece of code you write. You use commands to explain your intentions, because they're not obvious from the code alone. So when you do a query, remind yourself to use commands. I don't do that much in the slides because it takes place, and then I cannot do my trick with the query is simple because it fits, because it doesn't fit anymore. So I'm not using many commands, but you should. And so select star from greetings. It's not an interesting query, but it has a name, get all greetings. On the next slide, we load the file, and then we have queries that get all greetings here, the connections, and the get all users here. No, we didn't see it. Yeah, here it's returning that. So basically, those toolings are transforming the SQL-based tooling, are transforming SQL queries into function calls. Here it's Python, but you can see that it just, you have a queries magic thing, it's like a class, and you have a method, and the name of the method is the name that you gave to the query. Okay, so you transform a query into a function call, and you can call it with parameters and get results. And that's it. And so you can have in your source code SQL files, and then you use them as function calls. Okay? That's much better to handle than using an ORM. And also when you do that, and if you work in a company who has a DBA, and then you have a production incident, like performances are dropping in production, and you want the help of the DBA, you can turn over to the DBA with a link to your Git repository to this file, which is a SQL file, and you just send him a couple of parameters, and the DBA will be so happy about it. He can actually hack the file, make it, like fix the query, and then open a PR with the fixed query on it, all by himself. It will be empowered, and you are going to be too, because now your query is fixed. Yes?
I'm sorry to interrupt. That's a stupid question.
Yes.
But the name is terrible.
Which name? NoSQL? Yeah. Okay. Sorry about that. So next time I'm going to do it with SQL or maybe another of those guys. Sorry about that. So it's like annoying SQL. Is it like annoying SQL? No. Okay. Okay. So another thing you want to do when you write SQL that way is regression testing. So you're doing unit testing in your code, right? Nowadays, mostly everybody do. I wrote that in Go, but you can, like, it's a couple days of work anyway. So if you're doing Java, write it in Java, Python, whatever. It's the same idea as the regression tests that we do in the PostgreSQL source code itself. So it's really simple. You have queries, so you have them in your source code already. And then we do plans. So I picked YAML because in Go it's really easy. And in the YAML files you have mappings for the parameters. You say, this query I'm going to run it with this set of parameters and this other set of parameters, etc. And for each set of parameter, you're going to save the expected directory here. You're going to save the result of running it with pSQL. So you're going to do pSQL the query with the parameters and save the results. The results are here. And now you run it again, and you have the out directory, and you check that the out files are the same as the expected files with diff. You know, the diff tool from the 80s, it's still very useful. So you can diff the output here and here, and if there is any difference, well, you have a regression, so you can fix it. So it's really easy to consider that SQL is code, including integration into your workflow as a developer. Any questions so far? And then we do PostgreSQL extensions. So for me, extension is a long story, but it's also a good excuse to show a more powerful SQL and also to make PostgreSQL shine where you wouldn't expect it to. So I have a couple of nice examples. First one is geolocation. So the idea of geolocation is that you have an IP address, and we know where you are on the planet thanks to that. That's it. So your phone has an IP address. If you're connected to the Wi-Fi, your computer has a Wi-Fi address. And so here I'm using if you do host google.com, you have lots of IP addresses. That's one of them. Oh, and this operator, by the way, it reads contains. So I know you're going to say, well, it's strange, I'm not used to it. If you think about it, if you just take the double horizontal bar, the fact that this thing is called equal, it's not something obvious, right? It's something someone taught you at school or elsewhere. It's not something that when you see it the first time, you don't know what it means. This sign, the fact that it means greater than, again, someone taught you that. You wouldn't know if nobody told you, because it's not obvious, right? Maybe this one is a little more obvious than this one, but I don't know. And so this one, it reads contains, so you get used to it, and that's it. And PostgreSQL, because it's object-oriented, it knows that IP range here, the containment operator from an IP to an IP range, it knows what it means, right? So it's going to find the range of IP addresses here in the table that contains this IP address. And also what you can do, I don't think I have the example handy, but we can see the same query here. What we can do with PostgreSQL is we can implement an exclusion constraint, which means that we get the guarantee that there is no overlapping range on the database. PostgreSQL knows how to do that for you. So you can tell PostgreSQL, please, my location table, my blocks table, by the way, where I have the IP range, I refuse to have overlapping ranges. It's a single thing you put in the schema, and that's it. You have the guarantee. And so now when you do this query, you're guaranteed to have only one row as an output, because you have the guarantee that there is no overlapping, so this IP address, by definition, is only found in 0 or 1 range, right? So 0, no result set, and 1, you have one thing, which means that we can use that operator here, which is normally really frowned upon. If you do unit tests on your SQL, you should refuse that. That is a cross-join, it's a Cartesian product. So you multiply the number of rows from the pub names to the geolocation. But because we guarantee that we have only one here possible, so multiplied by 1, it's okay, right? But otherwise it's a bug here. And what we do here is that we have installed the extension called Earth Distance. So IP range is from the extensions named IP4R, which also supports IPv6, by the way, so it's historical name. And here we have this operator that is new. It's compute the Earth distance, but in miles, because an American guy implemented it. But you multiply by 1.609 and you have kilometers, so that's good. And this operator here is named distance. And so with PostgreSQL, you can order by the distance between the position of the pub and the geolocation that you are in, the location of the two. And you can limit 10, so you can get the 10 closest pubs nearby where you are now. And so the pub names, I got them from OpenStreetMap, and this was the IP address we had for the conference back in Dublin. So those are the 10 closest pub known to OpenStreetMap at the time, around the hotel of the conference. And of course, being in Dublin, you see that it's really close by. They have lots of pubs over there. They like it. And the order by limit, PostgreSQL is going to implement that with a single index scan, right? We call it a KNN scan. K is 10 here. We have 10 rows. It's K equals 10. And NN means nearest neighbors. So limit 10, so it's by distance, the 10 closest, so nearest. And neighbors, it's a generic name, KNN. And the KNN search in PostgreSQL is a single index scan, thanks to gist indexing. So this query on my laptop ran in like 2 milliseconds, something like that. So which, you know, leaves enough room for the developer to make like a nice map application on top of it. And it's, you see, so geolocation and finding all the pubs around you, it's a single SQL query. And it's a really easy one, right? Oh, another example that I like. That's, again, picking on MongoDB, because it's really easy to do, right? So MongoDB, some years ago, they implemented aggregates. They were like, yeah, we now have aggregates. It's awesome. And we were like in the SQL community, yeah, we've been having them for 40 years. We know it's awesome, right? And in a very long article with many different aggregates, they picked the example of the whole dataset of the NBA games that is open data. It's available as a JSON file or set of files, maybe. So they loaded the JSON because it's MongoDB, that's easy. And they say that, so interesting factoid, the team that recorded the fewest defensive rebounds. You know what it is in basketball? So it's when someone tries to hit a point, but the ball gets out, and then the team defending gets the ball and then can go and mark their own. So it's defensive rebounds. The ball doesn't fit into the point, it gets out, so it's a rebound, and defensive, you're in defense, you get it. And usually, when you're good at that, you win the game. But some games happened so that they were really bad at defensive rebounds and still won the game. So it's a really interesting statistics if you're into basketball. And they said, it's interesting because there was only one in the whole history of the NBA, one game, where it happened that they won, despite only recording the minimum defensive rebounds of the whole history of the game, which was 14. And when I'm reading this article, I was like, what's really interesting, you know what it is? They didn't show the query to get the result. Why would that be? So maybe it's really hard to do in MongoDB, I don't know. So I was like, okay, let's do it in, SQL. So it looks like this. And so first we're going to get the minimum number of defensive rebounds, but we're not going to hard code it. We could do this query, like minimum, and then input 14 in the other query, but it's, it would be tricking. So instead we're going to compute the minimum of defensive rebound over, so I told you over introduces the p rows. Here, if I say nothing, every row is my friend, so I get the minimum of the whole dataset, okay? So that's the minimum number of rebounds of any statistics from the games. And here I will limit my result to only the games where the number of defensive rebounds is the minimum. Okay? So that's easy. I have the in the processing here I will only process the games with the minimum numbers of defensive rebounds. And what I do is some displaying, and I'm going to fetch from the statistics the game entry, and from the game entry the team that hosted the game and the team that was a guest, and etc. And the result is that there were 4 games. So they were right about 14. That's good. But they only found the first one. It's 4 of them. So I'm not so sure about MongoDB aggregates, or maybe it was the guy who wrote the article, I don't know. But what I know is that they didn't show the query. And the query is like this simple in SQL, So I don't know why they wouldn't show it in MongoDB anyway. And another one that is fun for me, I hope it will be fun for you also. So, as developers, maybe you did some MVC before? Yes, question. This one, in the MongoDB article, they had a link to the NBA dataset in JSON. So I imported the dataset in PostgreSQL. Yeah. Oh, but this JSON data, it's not. But it's not one line per tuple. So pgloader would be good at one line per tuple. With JSON, you need to map the schema into a relational database, and so there is a ToroDB product from Alvaro with an extension called the Stampede, and they know how to do that. So for that, it would be ToroDB and Stampede. It would not be pgloader. And so this one. Unless you have another question, maybe, or other questions. No. So this one is MVC in SQL, so model, view, controller. You've done that before as a developer, right? The model, the view, and the controller. So that's the view. We're going to repeat this Unicode character as many times as the frequency with a rule, because the slide is not so big, so I only wanted to use 30 columns. Okay, so depending on the frequency, we're going to use up to 30 columns of this character in the slide, and we call it a bar. And that is the model, and that is the control. So the model is the number of defensive rebounds. So the question is, because we saw in the previous result set, we saw that okay, the 14 is the minimum number of defensive rebounds, but it doesn't tell us the average, or the average is useless anyway. But it doesn't tell us the frequency of the repartition, the histogram of the defensive rebounds in the history of NBA. What is 14 something really strange and weird, or is it an outlier, a common value? How can we know that? So you know what a histogram is, right? If you go to the market and you buy apples, they're going to have apples in different baskets, And any given basket is going to have all the apples of the same size, and then bigger apples, and then bigger apples, and the price is different depending on where you pick the apple on the basket. So it used to be that way. So that's an histogram. So we're going to draw an histogram of the frequency of the defensive rebounds in the whole history of the NBA. Using with bucket in PostgreSQL, I'm going to have that many buckets, and I'm going to have every defensive rebound number fit into one of the buckets that are between min and max computed here, and then I'm going to count the number of games that had this number of defensive rebounds. That's my frequency, and I'm also keeping, because it's more interesting, the range of minimum to maximum defensive rebounds in this bucket, okay, because I group by buckets. And there you go. So 14, yeah, that's very strange. 14, it fits in here. And usually NBA games, they have between 25 and 35 defensive rebounds per game, okay? So if you want to have like a quick histogram in, because you have a question at lunchtime for something in your database, like it's, you know, this query is like, what? This is always the same. This is like easily adjustable to your dataset. This is like copy-paste, you change 3 things. So it's like, once you know how to do this, it's like 5 minutes max, and then you have an histogram, and it's visual, and you see the data already. Ask me 2 questions about anything we said in this talk. Who wants to be asking the first question? Yes? Yes.
Why didn't you make a copy from program formatting from a bash script?
So, yeah.
Okay. My question was related to the first slide. So the proposed script to importing and formatting the data was directly copied from the CSV file and then formatting a second step.
Yeah.
And why didn't you copy from program?
So
some formatting on the fly.
So for 2 reasons. The first one is when I wrote the slide the first time, it didn't exist yet, the copy from program. So nowadays you can here, rather than copying from the file, you could have a small program like maybe Hawk or maybe grep or sed or something that would pre-process the data for you. So instead it would be really easy to remove the commas and the dollars, right? So you could invoke sed here on the file and copy the output of the program. That's really easy to do. So I didn't do that. First, because when I first did that, we didn't have this option yet. And second, because it doesn't work. Okay, I need maybe to do that. Yeah, I really wanted to show that. Because not many people, because of ORMs, that's my take on it. I'm not sure if it's true, but many developers for the schema, they use tooling that goes with the ORM that will manage the schema and do the migrations for them. And when the ORM does a migration where you alter 3 columns, you will have 3 alter table statements, which means 3 times a full rewrite of the table. And it's a bad thing. You want to minimize the number of rewrites of the table. So being able to show that you can do 3 different rewrites in the same table in a single statement, it was important for me in the slide. So if we had used a copy from program, then I lost the opportunity of showing that. Any other question? I think you had one. Okay.
So first, do you remember you were talking about a special sorting algorithm that it was coming from the 80s, that it was
yes.
very powerful for disk.
Yes.
What about the disk that we have today, the solid state disk? Do we have anything in Postgres that is available and is speeding up?
That's a very good question, because it's supposed to be that with SSDs you have a random access that is the same as sequential access. But each time there is someone who shows up on list with a new algorithm for that, it turns out that when you test it and benchmark it, because the resting disk have so many layers of cache, the actual performance is not so different. So we have people taking care of that regularly, wanting to optimize the I/O performance of PostgreSQL, but currently that's not where the problems are in Postgres. We have other bottlenecks that are completely hiding that. And Andres is going to remove them maybe in PG12. So going to be interesting.
Okay. And the second question, at the beginning, you were talking about the PG loader that is transforming whatever into Postgres.
Yes.
But for whatever reason, you didn't mention Oracle.
Not yet. But conceptually, it would be really...
It was by intention.
Yes.
Uh-huh.
So the first thing I did with this thing was support for MySQL, because I feel really sorry about MySQL users. And most of them, they are, the one I know actually, are open source projects. And I picked MySQL because they don't know better. And I'm really sorry about them.
Yeah.
I wanted to make sure that open source project didn't have an excuse to say, no, it's too complex to move over. So I did that for many customers using MySQL, and then I was like, okay, I'm going to open source it, so that open source project that I want to use, because when I see an open source project and it's not using PostgreSQL, I'm not using it, usually. So if it's using MySQL, I don't care. I don't want my data in MySQL, never. I know what it's doing with it, and it's nothing I'm interested into. So that was the kickstart of it. And then after that, I added SQLite, same reason, and then some others. Microsoft SQL Server, it was sponsored, so someone paid me to do it. So I'm happy to do Oracle.
Working on Linux.
Sorry?
It's working on Linux. So
yes, yeah.
No complaints.
It's not open source. I don't care about things that are not open source. I've been in this career for 20 years doing only open source, and I hope I can continue doing so. So it's personal. It's we all have different ways to see the world. I don't mind, but personally, I do open source. And so Microsoft SQL Server, adding support for it into pgloader is cool because it allows people to use PostgreSQL, which is open source. So I'm okay with that. But it was sponsored, it was paid for. And Oracle, nobody paid me to do it yet. So you have two ways to sponsor a pgloader, it's as usual in open source. Either you give money, or you give your own time, and you send patches, and I will be happy to integrate the patches for support for Oracle. But if you don't want to do it for some reasons, you can also send money and someone else will do it. So Oracle is on the list, yes. I'm interested into doing it. Okay, let's make it happen.
So let me understand this. So pgloader is basically an engine, and you have a plugin, one for MySQL, the other one is for... Okay.
We can say it that way.
Exactly.
It's not implemented that way.
Like this. Okay. Yes. Yeah. Thank you.
Yes, sure.
Someone else?
Any other questions? No? Yes? Yes.
In the queries show about the laterals and common table expression,
yes.
How hard is to create an index that makes the performance really good in the query?
Okay, so there are two rules about, so we call it the optimization club, people who want to optimize things. And so, like, you know, there was some other clubs that are famous. Do you know the first rule of the optimization club? Exactly, you don't do it. And the second rule of it is for experts only. And expert means you've done all the mistakes that are possible to do and you remember about them so that you won't make them again. So for being an expert in any domain, it's easy, you do all the mistakes. So I'm an expert in PostgreSQL, I cannot tell you how many mistakes I've done before. So second rule of optimization club is for expert only, don't do it yet. And more seriously, the only way to figure that out is with your own dataset, like your real production dataset, and explain analyze. That's the only way forward. If you're using PostgreSQL, you need to be able to read, explain analyze. You have online tools like explain.dpage.com and some others. OmniDB is like a nice UI for PostgreSQL where you can run the queries, and they have a really nice flame graph support for explain analyze. So play around with it, understand explain analyze, and the answer about what to index will usually be obvious enough. There is no generic answer to indexing. The only generic answer there is that an index, so in the SQL standard, there is no index, right? Indexes are not covered in the standard. So anything you do in SQL, you can do it with or without indexes. Indexes is something on top of SQL to implement faster access to the data. It's all about getting to the data faster. It doesn't change the semantics of the queries. So you don't need indexes to do SQL. You only need them to provide a faster access path to the data. That's it. And the index are only relevant when you have a data set and a query. There is no reason why to create an index if you don't have a query. There is an exception to that, of course, because Word would be too simple otherwise. In PostgreSQL, some indexes are relevant to back constraint. If you want a primary key, PostgreSQL only knows how to do that with an index because of the, the ACID tricks and the transaction we said before. An index in PostgreSQL obeys to different semantics in terms of visibility, so it will be able to see things that are not committed yet, which allow it to guarantee uniqueness even if there is two people trying to insert into the same value at the same time in the same table. So there is some tricks. So apart from constraints, indexes are only useful if you have a data set and a query, or a set of queries. So who's writing the queries? The developers, right? So who's responsible for designing your index strategy? Well, the guys who write the queries in the first place, so the developers, of course. So the only generic approach to indexing is it's the job of the developer. It only is meaningful for a given query or a given set of query, and the only way to figure out if it's beneficial for your case is with the real data set and explain analyze. So I'm sorry it's hard work, but you need to do it.
Okay, thank you.
Yeah, and the lateral looks a little scary, but it doesn't change anything about that. It's as usual. Yes?
Yeah, I wanted to know what's the difference in terms of computation when you do a left join, for instance, and you add, left join on whatever,
yes,
and you add a condition in the AND clause. The difference between putting a where.
Okay, so there are a semantic difference.
Yeah.
So if you do a left join and you have several clauses, and one of them is and I don't know, room ID equals something,
Okay.
It means you're only going to join with the rows that have this property. But if it's in the where clause, you're going to join with rows that don't have it also. So look into it, but there is a semantic difference. And then the question was more in terms of algorithm.
Yeah, in terms of computation, like what's like the cost?
So basically, you can write it in what's your favorite programming language? Python, Java, Ruby?
Yeah, Python could be.
Python, you said?
Yeah.
Yes. So you can write a left join in Python. It's easy. You do a loop and then another loop, and you join the query like we did before. Right, in one of the slides we had a loop that were doing a hash probe, like look into a dictionary that you loaded before. It's exactly what PostgreSQL is going to do for you. And it has three different algorithms for doing joins: nested loops, hash joins, and merge joins. So nested loop, you loop over the first table, and for each row you loop over the rows of the next table. That's the most efficient technique in one case only. It's when you can guarantee that for each row on the left you have only one row that matches on the right. So if you look joining over a primary key index, usually you do that. In any other case, it's the worst possible solution. And it's really easy to do in your application too. It's just a loop over loop. Then you have the hash join. It requires to first build a hash table in memory, and then for each line you probe into the hash table, and if the row is there in the hash table, you go fetch it from the database. And then you have the merge join. You sort the two tables, and then you run through the tables. So you're in the letters like you have two dictionaries. Basically, it's sorted already, and you're going to see any word that is in the dictionary here, but not in this one. So you take the A, and then you search in the A until you have it, and then you go, and then you go, and then you go, and then you go. And PostgreSQL is going to do that. It's called a merge join. So in terms of computational complexity, basically it's either one of the three algorithms that is going to be implemented by PostgreSQL, but with some subtleties. It's either on top of a full scan, or on top of an index scan, maybe on top of an aggregate, maybe on top of a limit, etc. So the only answer again is explain, analyze.
Okay, thank you.
Sure. Yes.
So you said Citrus is doing sharding to filter data faster.
Yes.
What's the difference between sharding and partitions?
It's so if you partition by a key, it's exactly the same thing. The only difference is that sharding happens on more than one server. So rather than having a partition on the same machine, you have this partition of data, we call it a shard, and now it's hosted on another server, which means that instead of trying to have more and more and more memory, so the limit nowadays, I think in AWS, it's 6 terabytes of memory, RAM, in a EC2 instance. So rather than growing up to 6 terabytes in one single node, you can have many different nodes and have like the sum of the memory of everybody, but also the CPUs and also the I/O bandwidth. But otherwise, it's like partitioning. Conceptually, it's about the same thing. Any other question? So, pizza.
Yeah, actually, it's on the way.
So more questions.
Officially, it's delivered.
Okay. Yes?
What about if I tell you my favorite programming?
With microphone, if you don't mind.
Ah, yes.
What about if I tell you my favorite programming language is Scala?
Mine is Common Lisp. So
No.
okay.
What I mean is, you told us that SQL is object oriented and so on.
Yes.
Does it have anything like functional programming in it? In SQL or not?
Usually, functional programming is all about. So there are two things about functional programming. It's higher order functions and being free of side effects. So the database is all about side effects, right? So the whole goal of the database is to handle insert, update, delete. That goes with a lot of side effects. So by that definition, it's not like purely functional, like they say in functional programming circles. And then the other side is higher order functions. So it's the ability to combine, like map reduce is the poster child of that. So you can map over a result set that you've been reducing before that, etc. But that aggregates in SQL.
Okay.
And as we saw before, so when you do a SQL query, it's really easy to compose them.
Yeah.
In functional programming, you have higher order functions, so you will filter over a map, over something else. In SQL, you can say select blah 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 from a subselect, from a subselect, from a subselect. So you can actually compare that to higher order functions if you want to, if you're so inclined.
Yeah.
So I'm not sure how useful it is, but that would be my answer.
Yeah, thank you.
Okay, so you have covered a lot of useful stuff that Postgres has.
Yes.
Now, Postgres is not perfect. Close to, but not there, right?
Yeah.
So, what SQL feature you think Postgres is maybe missing? Which one would you like Postgres to have in SQL that doesn't have right now, that you have dreamed of or suffered?
Yes, my favorite would be as of time travel.
Me too.
Yes, it's so for maybe not everybody knows about it, but in the SQL standard you can do a query as of a timestamp. So you can see the data as of yesterday, for example, or as of the closing of the financial year, or as of this transaction ID that is problematic because now there is a customer that is complaining about something, and they're saying it's wrong, and you need to have a precise look, and you can have a snapshot of the whole database as of this time, without having to do anything about. You don't need to restore backup, or PITR allows you to do that, but in the standard you can do it in any query. So you can have different, like we said before, you can have concurrent queries in PostgreSQL using different snapshots. You can have a pgdump that's running for 3 hours with a single snapshot for the whole duration of it. And in parallel to that, you can have your own application doing a select, inserts, whatever it does, with other snapshots. And you can have two different concurrent users having each one their own snapshot because they did not enter the system at the same time. It's all integrated in PostgreSQL already. What you cannot do is query any arbitrary snapshot in the past. It would be nice to have. Yeah. And then there would be standard compliant temporary tables, and then materialized views. We have that, but we don't know how to update them online. I would like to have that. And then I would like to have queues also. like a table, but it's like, you know, we have tables and we have unlogged tables. I would like to have logged only tables.
Yeah, my favorite one is also as of.
Yeah. Yeah. Oracle used to have as of. It's called flashback in Oracle, I think.
So the question was very easy. Is there any product on the market that is implementing this functionality already?
So the way the SQL standard works is that it's a competition in between Oracle, IBM, and Microsoft. So what happens is in big companies, they have people responsible for buying things, and they know nothing about what they buy. They're here to negotiate the price terms and the contracts and things, and so they will look at the product sheet and compare them. And so they will look at the features that the guys have implemented in the standard, and you have the checkbox game. Do you check this box? Yes, this one, etc. And so they will compare the product like this. And so the game of IBM, Oracle, and Microsoft is to have more boxes in the standard that they checked, but not the others. So anything you have in the standard has been implemented at least once. And the most useful things have been implemented 3 times, 4 with PostgreSQL nowadays, etc., etc. But some weird things have been implemented only once, and that's why also SQL syntax is so strange, because if you manage to have in the standard a really completely strange syntax, to remain polite, it will be much harder for the other guys to implement it. If the syntax is obvious, it fits into whatever exists already, that's easy to implement. But they want to keep an edge like for a couple of years before the other guys have it. So that's the behind-the-scene game of the SQL standard. Not so pretty, but politics has it best. And I see the pizza, so if you want to ask a question, I'm happy to answer. If you prefer to have pizza, I can understand.
Yeah, let's do pizza, then you're going to be around anyway.
Yes.
So thank you so much for